during going over the pre-calc quiz number 6, versions Q and S, taken on November 5th, 2018. Determine if the function is even, odd, or neither. So here you're going to put in negative x. That's a negative. And then negative x times negative x times negative x is negative x cubed. Oops, forgot to put the negative x here. Negative times negative is a positive, and this becomes negative 2x. So here this doesn't look like the original one, but if you factor out a negative, remember that's a positive and then becomes a negative. So here you have the original function, and it's the opposite of the original function that is a odd is your answer. If it becomes the original function, then that would have been even, and if it's not the original function, and if it's not the opposite of the original function, then that would be neither. Question number 2. Consider the function h as defined. Find functions f and g so that f of g of x equals h of x. So here I have h of x, and if you circle that or highlight that we did in class, then I can call my g of x 4x plus 2, because right here this is kind of written as g of x. You can put g of x inside of f. So the innermost part is g of x, just 4x plus 2, and then the part I didn't circle or highlight is the absolute value of x. So basically putting all of this into the x value looks like our h of x, so we're making two simple ones. It's not this one because it doesn't have the negative sign in front. You could call f of, that should be f of x, g of x, but they don't have to be the absolute value, so not that one. Here you don't want the opposite. Here, 4x plus 2, this is our correct answer, C. Match the graph by writing the appropriate basic function in the first blank, and then the equation and function in the second one. So the first one here, we have a, they call this a natural log, or you can also call this natural logarithmic function. And the equation is y equals ln x, or f of x equals ln x. Number 2, this is a quadratic function. It's quadratic, and its equation is to the power of 2. This should say number 3, and this should say number 4. Graph 3 here. Here I'm starting at 0 and ending at 0. This would be the sine function. And y equals sine of x. Number 4 here, this is called the greatest integer function. Greatest integer function. You can write your equation like this. This would be acceptable. We talked about in class. You can also do this one. Or y equals integer x, which is kind of a calculator function, but any of these would be fully acceptable. You don't have to have all of them. Question number 4. Which of the graphs provided in question number 3 above, which of the graphs are bounded? So bounded means above and below. And here, this one is bounded just above. This one is bounded below. This is a bounded above and below, so this one is bounded, so number 3. And this one keeps going on forever, so this graph will be unbounded. Which of the graphs have even symmetry? So my trick there is the word evenly. And that's kind of to show you that it should be symmetrical over the y-axis. So if I fold it here, it would go across, so that would be graph number 2. This would not. That would have to have a graph that looks something like that. Over here now, you might think that it works. Let's see if my mirror works. And you'll see that it looks kind of like a mustache, but it does not exactly. So not graph 3, and this would kind of come over here, so not graph 4, so just graph 2. And then that side was out of 18 points. Turn to the back side. Alright, let's go over the back side of version Q and S. For your response, make sure to show all your work and box your answers given f of x equals x plus 2 and g of x equals x to the third power. Find the following along with their domain. So I'm going to go ahead and find the domain of each of these. And if you need a graph, go ahead and graph it. X plus 2 is just a linear. Remember, domain means going left to right. You're going from left to right here. You're starting on the x values that are negative infinity, and the x values are positive infinity. So don't think it's negative infinity because it's pointing down. You could have had the slope like this, and that would be negative infinity to positive infinity. And then x cubed, our graph looks like this. Same thing, negative infinity to positive infinity, because you have your two arrows. Find A tells you add f to function of g. So x plus 2. Remember, when you're doing your substitution, put in parentheses and x cubed. Notice how these are not like terms, and we don't need the parentheses because of the plus sign, so I can write this in descending order, meaning looking at the exponent. X to the third, x to the first, 2x to the 0, with a domain of negative infinity to positive infinity. And basically here you're just looking for the most restrictive domain. Which parent, which one has the most restrictions? Which one is more strict? Alright, let's do a subtraction. Function of f subtracted by the function of g. So x plus 2 minus x cubed. And again, they're not like terms. Here I can distribute the negative, so this becomes negative x cubed plus x plus 2, descending order with a domain of negative infinity to positive infinity. The only time that this is actually going to be different is if you have like the square roots, rational functions, division, which we're going to see in part D. This one here is f times g because there's no math operation, so f is x plus 2 and g is x cubed. So here I'm going to be multiplying. I get x to the fourth plus 2x to the third with a domain. Most restrictive would be, well, they're both the same, so you can just pick that. And f divided by g here, so I have x plus 2 over x to the third. Remember, don't do anything crazy like canceling the x's, because this is not a factor, this is added. That basically means they're separated by addition. These are multiplication. You can only cancel if they're both multiplication. Now, with a domain, now we've talked about finding the domain algebraically. That basically means setting this not equal to 0. And you're basically finding the cube root of that. 3 identical numbers that multiply to be 0. That number is 0. 0 times 0 times 0 is 0. So x cannot be 0. And when you're writing integral notation, that basically means negative infinity to 0. Don't include 0. And you pick any positive number. So that's our answer for number 6. Number 7, graph f of x equals 2x plus 1. We talked about a boundary here at 1. Got lucky there, it's the same number. Remember, this line, yellow line, is not a vertical asymptote nor a vertical line. It's just a boundary to help us. You can put this into your calculator and get some values. Here you want values that are bigger than 1, equal to, so I'm starting at 1, then I go up to right 1, up to right 1, rise of 2, right of 1. And it's equals to, so it's going to be a solid. And that's what my graph looks like. And if you struggle with that, you can put it into your calculator. X plus 1. And go to your table, and then you want values that are 1 or greater. So 1, 3, 5, 7. 1, 2, 3, 3, 5, 7. Remember the calculator commands for my calculator, sorry, I got a glare, is you want to go to second window and make sure those are on auto and auto. Okay. This graph, y equals x squared plus 3. This one has a restriction of less than 1. So numbers that are smaller this direction, so that would be the negative numbers from your calculator. X squared plus 3. And I want numbers that are smaller than 1. So I want 4, 0, which is 3, negative 1, 4, negative 2, and that's 7. So basically the parent function is quadratic, and it's being just shifted up 3 units. So 1, 4. So here it's going to be an open circle. The reason why it's an open circle because it has a less than sign. 0, 3, negative 1, 4, and negative 2, 7. So my graph's going to look something like this. And basically those are not touching. Okay? Question number 8. Graph the function. Make sure to include asymptotes and a table of values. So we talked about how to graph these with your x-intercept. So y equals 0. My equation doesn't have a y, so we're making it f of x equals y. Make this 0. And you're going to make the 0 fraction by putting it over 1. So if you multiply, cross multiply, you're going to get 0 times anything is 0, and 1 times x is x. So x equals 0 is a, that means your x value is 0 and your y value is 0. So my order pair is 0, 0. Y-intercept, I'm going to make x equal to 0. So y equals 0 over 0 plus 1. Y equals 0 over 1. Y equals 0. So that means when x was equal to 0, my y value is 0. So it just so happens that in this problem that the origin is both our x and our y-intercept. Let's talk about our vertical asymptotes. Vertical asymptote is basically taking the denominator and saying that not equal to 0. Subtract 1, and you have x is not equals to negative 1. Because if you take negative 1 and put it in here, negative 1 plus 1 is 0. Anything divided by 0 is bad, that is undefined. Horizontal asymptote. Here I'm going to compare the highest degree. So the highest degree here is 1. This one is x to 0, so that's a 1. So 1 to 1. That is equal. And then you compare that with our chart. When it's equal, it just tells you to reduce. So this one is kind of like 1x over 1x. Remember, when you're kind of canceling here equals 1. So y equals 1 is going to be our horizontal asymptote. Let's graph the horizontal asymptote. Horizontal means left to right. Here at 1. I'm going to do a dotted line. Let's do our vertical asymptote at -1. There's my graph. And if you think about it, if -1 is kind of like my middle, I want a couple of values that are smaller and a couple of values that are bigger. Put that into the calculator. Y equals, I have x divided by x plus 1 copy down my values. I put mine to the 10th unless it is needed. When it says error, that's undefined there. 0, 0, which we already knew. 1.5 and 0.67. I'm going to graph this with my pencil. So -4, 1, 2, 3, 4. Just notice that it is above the line because that's 1, so it's like 1.3. And what's happening to these values is they're getting bigger. That's all you need to know. -2, 2. And then you just graph it. Undefined here, and then 0, 0, which we already knew because of our two x and y intercepts. Sorry. 0, 0, 1, and 1.5. And just notice what's happening to these values. They're getting bigger. So it's approaching here. Graph looks like, and if you did zoom 6 on your graph looks just like that. So you're kind of just verifying to us if you do it by hand. So that side was 24 points, this side 18, and